today we'll be doing the integral from 0 to infinity of 1 divided by the square root of x times 1 plus x squared dx. And to start off, we'll make a substitution. So I'm going to let u equal x squared, which means that the square root of u is equal to x, which means that dx is 1 over 2 u to the 1/2 du. And that also means that u sub 1 is 0 and u sub 2 is infinity, so the bounds don't change. It is equal to the integral from 0 to infinity of 1 divided by the square root of x. So if x equals u to the 1/2, then that means that x to the 1/2 equals u to the 1/4 power. So it's u to the 1/4 power times 1 plus u, and dx is times 1 over 2 times u to the 1/2 du. If I bring down the 1/2, this is equal to 1/2 the integral from 0 to infinity of 1 over u to the 1/4 times u to the 1/2 times 1 plus u du. So u to the 1/4 times u to the 1/2 is the same thing as u to the 1/4 plus a half, is equal to u to the 2 plus 4 times divided by 2 times 4, which is equal to u to the 6 over 8, which is equal to u 2 times 3, and then divided by 2 times 4. 2's cancel, and we're left with u to the 3/4. So this is equal to 1/2 the integral from 0 to infinity of 1 over u to the 3/4, 1 plus u du, and we can rewrite this as 1/2 integral from 0 to infinity of u to the -3/4 divided by 1 plus u du. So we just got done showing that the integral from 0 to infinity of 1 divided by the square root of x times 1 plus x squared dx is equal to 1/2 the integral from 0 to infinity of u to the -3/4 divided by 1 plus u du. And we will utilize a special function called the beta function. And it says that beta of m comma n is equal to the integral from 0 to infinity of u to the m minus 1 divided by 1 plus u to the m plus n power du. And we'll just match coefficients. So we'll have m minus 1 equals -3/4. We have m plus n is equal to 1. So if we solve for m and n, we have m is -3/4 plus 1, which is equal to -3/4 plus 4 over 4, which is equal to 1/4. So we have m equals 1/4, and we have that n equals 1 minus m, but this is equal to 1 minus 1/4, which is equal to 3/4. So we have now n is equal to 3/4. So our original integral from 0 to infinity of 1 divided by the square root of x times 1 plus x squared dx is 1/2 beta of m comma n, but that's 1/4, and n is 3/4. And I recall another identity that beta of m comma n is the same thing as gamma of m times gamma of n divided by gamma of m plus n. So the integral from 0 to infinity of 1 divided by the square root of x times 1 plus x squared dx is 1/2 of gamma of 1/4 times gamma of 3/4 divided by gamma of 1/4 plus 3/4. It's the same thing as 1/2 of gamma of 1/4 times gamma of 3/4, and 1/4 plus 3/4 is 4 over 4, which is 1, so you have gamma of 1. But gamma of 1 is the same thing as 1 minus 1 factorial, which is equal to 0 factorial, which is equal to 1. So this is just 1. We have that our integral from 0 to infinity of 1 divided by the square root of x times 1 plus x squared dx is equal to 1/2 of gamma to the 1/4 times gamma of 3/4. And I'll write 3/4, the same thing as 4 minus 1 divided by 4, which is 1 minus a fourth. So this is equal to 1/2 gamma of 1/4 times gamma of 1 minus a fourth. And I use Euler's reflection formula, another nice identity, that gamma of z times gamma of 1 minus z is equal to pi cosecant of pi z. Here we could see that z is equal to 1/4. So we just have 1/2 of pi cosecant of pi times a fourth, which is pi over 4. And we know that the sign of pi over 4 is the square root of 2 over 2, but cosecant is opposite of that, so cosecant of pi over 4 is 2 divided by the square root of 2. So in the end, we have 1/2 times pi times 2 divided by the square root of 2. And as you can see, the 2's divide to 1. We're left with pi divided by the square root of 2. So in the end, we have that the integral from 0 to infinity of 1 divided by the square root of x times 1 plus x squared dx is equal to pi divided by the square root of 2. And this is the final answer. Thank you very much for watching.